Okay, looks like we are good to go. So it's a very warm welcome to this third Druid Summit. And since they've all been virtual, we can say that we're probably the only big data conference where pants have been optional from the get-go. So anyway, my name is Rachel Podreski. I'm the head of the community program here at Imply. Many thanks to the people who have already spoken today. So if you're just joining us, be sure to check out the recordings, which will be sent out later this week. We just heard from Satish and Chetnaya from Zeotap. And with great pleasure, I introduce our fourth session speaker, Yakir Buskila and Itai Yaffe Yakir is the Vice President of Research and Development and General Manager Israel for Nielsen Identity. And Itai is a Principal Solutions Architect here at Imply. Their presentation is entitled Casting the Spell, Druid in Practice. Love that title. But before we get started, we just have a few little housekeeping notes. So all the attendees will be on mute throughout the session, but this does not mean you can't ask questions. Actually, we encourage it. Just use that Q&A section down in the Zoom webinar panel, way down there. Q&A, and I will monitor those and make sure those get out to the presenters at the end of the session. Anything that we don't have to answer today, we will respond in a follow-up blog post. And links to the full presentation and accompanying slides will be sent out following the sessions, as I mentioned earlier. They'll be live tweeting throughout, so be sure to follow us on Twitter. Itai's been doing a great job of that so far today, so I don't know if he's going to actually live tweet his own session, but we'll see how well he can multitask. Anyway, welcome Yakir and Itai. It's over to you guys.
Thank you. All right, so hello everyone. I believe that if you ever dealt with big data, you probably ask yourself how you can ingest terabytes of data and how you can make this data available for customer-facing dashboards, and finally, how you can do all of that in a cost-efficient manner. So thank you for joining us today. This is exactly what we are going to discuss. We've been dealing with Druid for the past 5 years, and we believe that we have a very good answer to this question. So my name is Yakir. I'm leading the tech for Nielsen Identity. I mainly focus on big data and machine learning solutions. And with me today also Itai, who is currently a principal solutions architect at Imply, and previously worked with me at Nielsen. He was our big data group tech lead. And as you can see, Itai has been dealing with big data challenges for quite some time now. All right, so what we are going to cover. So first of all, we're gonna discuss data modeling, and we're gonna show you how to correctly model your data in order to avoid common pitfalls when you are going to ingest data into Druid. Then we will also discuss actually data ingestion and how to ingest terabytes of data into Druid efficiently. Then we will discuss retention and deletion, which is a very important topic, especially if you're dealing with big data sets, because you don't want to pay or store for data that you don't use. And finally, we will also discuss query optimization, and we will share with you some tips and tricks on how to efficiently write your queries. And of course, that we will show you how to leverage all that information in your organization. All right, so Nielsen, for those of you who don't know, is a data and measurement company, which means that we are collecting data from various sources. And our goal is to basically measure media consumption. We are mainly famous for measuring TV rating in United States, but again, we have multiple measurement products and we are doing this around the globe. Nielsen Identity, more specifically, is a business unit which develops an internal product, Nielsen Identity, that aim for, the goal of Nielsen Identity is basically to generate an holistic view of a consumer, which means that we are trying to build an anonymous profile from all the data points that we are collecting about a consumer. For example, we are trying to understand what are the different devices that are being used by a consumer, what are the different characteristics of this consumer. So for example, whether it's a male or female, what is the age of this consumer, things like that. And later, we are providing all this information to the other Nielsen products so they can provide better and more accurate insights. All right, so just to give you some sense of the scale of the data that we have. So we are processing more than 10 billion events every day in our Kafka clusters. We are running in our Spark clusters more than 3,000 nodes every day. On S3, we are storing more than 30 terabytes of data. And if you're talking about Druid, we are ingesting tens of terabytes of data every day. Okay, so I want to present to you two use cases that will help you understand the problems that we are trying to solve, and will also give you the background as to why we decided to use Druid and what we are using Druid for. So the first use case that I want to present is what we call building target audiences. In this use case, we are basically allowing our clients to define audiences, which later they can target. An audience in our world is a composition of devices that are sharing common attributes. So for example, our clients can define an audience of all the females in a specific age and with a specific interest. And we need to basically find all the devices that can be part or should be part of this audience. And in this screen, as you can also see in the blue box at the top, we are also calculating the number of unique devices in this audience. One more thing to notice here in this screen is that we are also allowing our client to define the relation between the different attributes. So for example, as I explained the example here, the client defined the end relation between the different attributes. So he's choosing all the females in a specific age and with a specific interest. So it's an end relation between the different attributes. And again, as I said earlier, in real time, we calculate the number of unique devices we have in this audience, and we show the number in the blue box. All right. So the second use case that I want to present is what we call funnel analysis. In this use case, we are basically helping our clients understanding better and analyzing their ad funnels. I will give you an example. Let's say that we have a client that is running an internet campaign. And the first part or the first stage of this campaign is just putting ads online somewhere. So, and some people who are surfing the internet will get exposed to this ad. So once they are exposed to this ad, we need to be able to count the number of unique persons that actually exposed to this ad. Now we count them as people in the awareness stage, because now they are aware to this product. Later, some of these people who got exposed to an ad are also surfing to a specific landing page. So now we need to be able to count the number of unique persons who first got exposed to an ad and later surfed to a landing page. Later, some of these persons who serve to this landing page also add some product to their shopping cart. So again, now our goal is to count the number of unique persons who first watch the ad, serve to a landing page, and then add a specific product to their shopping cart. And finally, of course, we also need to count the number of unique persons who actually purchased the product. So as you've seen, we have diverse use cases. When we try to think about what is the solutions that we want to build, we were looking for a single system that can help us solve these diverse use cases. We didn't want to have like a different system for each use case, because then you need to learn about a new system, you need to maintain a new system. So we really prefer to have only a single system. And this is exactly why we chose Druid. So Druid, because of its flexible architecture, because of its extensive query language, because of the ability to fine-tune specific components in the system, was a great fit for us. Now, if you also think about that, there is a common thread in these use cases. So essentially what we are trying to do is count the number of distinct elements. It can be unique persons, it can be unique devices, but we're talking about counting distinct elements. And we need to do that in real time because we have users that are waiting in the screen for an answer. So it cannot take minutes or hours to complete. And we also need to do that at scale because, as you've seen, we have a lot of data. So we need to scan all of the data for providing accurate answers. So unfortunately, if you are trying to solve the count distinct problem and do that in an accurate, safe, fast, and efficient way, there is no such solution. So what you do have is approximation algorithms. And in this family of algorithms, you're basically giving up on some of the accuracy. So you don't get the exact number of unique elements in your set, for example. You're getting some estimation, which should be close enough. But in return for the loss of accuracy, you get significant improvements in the performance of the solution and in the space requirements of the solutions. So this is why we decided to use Theta Sketch. This is the approximation algorithms that we decided to use. And Theta Sketch is based on the idea of K minimum values. K stands for the number of elements you store in your sample. It's a constant. And again, we are talking about approximation algorithms. So you don't need to store all the elements in your set. You just store a sample. And from this sample, you infer something about the general population. And minimum values refers to the process of selecting which elements will be stored in this sample. So minimum values here means that we are taking only the elements that generate the minimal hash values. With Theta Sketch and KMV, you can estimate set cardinality, which just means that you can get the number of unique elements in your set. And for us, the biggest benefit of Theta Sketch and KMV was its great support for set theoretic operations. So with Theta Sketch, we can calculate the intersection and the union between two sets. And for us, this is very important because as I've shown you in the first use case, we need to be able to calculate the number of females in a specific age. So this is an intersection query. This is an intersection between the set that represents all the females in the world and the set that represents all the persons in a specific age. The only downsides that we found with Theta Sketch was when we tried to intersect a very small set with a very big set. Only in this specific use case, the error was, like the accuracy was problematic and the error could get quite high. But Itai will share with you some ideas and ways on how you can model your data so you can avoid this problem. All right, so we have Theta Sketch, but we also needed a concrete implementation. So luckily for us, Theta Sketch is being supported in Druid via the great data sketches library from Yao. By the way, I encourage all of you to go to Data Sketches website. They're offering plenty of sketches that can help you solve many problems. I'm sure that you can find a sketch that will be helpful for your problem. The way that Theta Sketch works in Druid is that during ingestion time, based on your ingestion configuration, the different sketches are being created and stored as Druid segments. And then during query time, Druid is pulling the different sketches and perform the additional aggregation. Usually for union and intersection, these aggregations are being done during the post-aggregation phase. And what you get as the final result is basically the estimated number of unique entries from the final aggregated sketch. Now, we presented Theta Sketch many times in the past in previous talks. So if you are interested to learn more and understand how it works behind the scenes, you can go and watch these short videos that we presented previously. And we also, if you're interested in to learn more and find more information, you can also look for search for some of our past talks online. All right, so we presented the problem that we have count these things. We said that we can use Theta Sketch and we said that we can also use Druid, but now we had to build the full pipelines that combine all of these components into a single solution. So Itai will show you how exactly we did that. Itai, to you.
Thank you. Okay. So as you can see, we have the high-level overview of our data pipeline. And as you can mention, we have a lot of raw data, billions of events coming in every day into our Kafka clusters. They're being processed by Spark applications that produce Parquet files on S3. And from there, we ingest it using the Hadoop-based ingestion into S3 as our deep storage to be loaded into Druid and be accessible for queries from our SaaS application. Now, I'm gonna go over and deep dive into each of the sections and provide some guidelines and tips on how to optimize them in your organization. So let's start with data modeling. And this is really a sample data, somewhat similar to what the folks from Zeotap showed in the previous session. So we have a timestamp of the event. We have an audience name, which is basically some kind of characteristic of the device that's being used, you know, mobile, football fans, etc. And we have the device ID, which performed the operation or which we identified as being mobile or belong to some other audience. Now, if you want to know how many unique devices were used from mobile for a given date, we'll actually have to go through all the raw data at query time, scan it, and produce the answer, which, as Yakir mentioned, is probably not fast, not resource efficient, etc. So a better approach would be to actually use the Theta Sketch metric. And then rather than have the device ID, we'll have a Theta Sketch metric, which on ingestion time will roll up those device IDs into a Theta Sketch object. And then what we will do at query time, or what Druid will do behind the scenes, is actually to take the matching Theta Sketch object for the query that we sent. So again, say mobile devices for a specific timestamp. And it will extrapolate the approximate number of unique devices that were used for mobile in this given date using the Theta Sketch object. Now, that's not enough for us because we usually need some kind of relations between audiences. So, for example, intersections or union. So if we want to know how many devices were used by Druid committers from tablets, we'll have to intersect those two Theta Sketch objects. Now, if you recall, Yakir mentioned that the intersection of a large set, like the number of devices used by tablets or that are tablets, is a very large set. However, unfortunately for us, the number of Druid committers is much smaller. So intersecting these two Theta Sketch objects will probably result in a somewhat high error rate. So to mitigate that, what we can do is we can extract the device type into a new dimension. And so if we want to know in this new data model, what is the approximated number of Druid committers using tablet or for a given date, there is no intersection. We can actually take the specific Theta Sketch object and do the extrapolation of the approximated count distinct. So that's with regards to Theta Sketch intersections. And another thing with regards to data modeling is slowly changing dimensions. Now, unfortunately, Peter Marshall is not the MC at the moment, but he probably knows that football and American football is not the same thing. So let's say that we decide that the audience name should no longer be football fans, but rather American football fans. So in the naive approach, what we'll have to do is we'll have to go through the entire data in the data source and either reindex the data or find some other way to update it. A better approach would be to leverage lookups. So lookups are basically mappings between some kind of an ID, like the audience ID here, and a string, which in our case is the audience name. This mapping can be placed in files or more appropriately in relational database, and can be pulled by Druid periodically into memory. And so what we'll do is, rather than storing the audience name in the fact table, we'll actually use the audience ID. And then at query time, what we can do is we can either use the lookup function to map the audience ID to the audience name and serve that result to the user, because the user usually doesn't know what the audience ID means, only the audience name. And another option would be, if you're using a newer Druid version, is to use a join between the fact table and the lookup table. And finally, now if we want to change the audience name from football fans to American football fans, we only need to change it in one place, which is the lookup table itself. So to summarize this subsection for data modeling, you can use Theta Sketch for fast and efficient count distinct, but pay attention to intersections. You can also leverage lookups to handle slowly changing dimensions. And finally, we encourage you to check out the schema design page on Druid's website to get some more guidelines and understanding on how you should model your data. Okay, so we model our data, now we need to ingest it. So as you know, there are a few ways to ingest data into Druid. So you can ingest data in real time, for example, through Kafka or Kinesis. And you can also ingest data in batch using the Hadoop-based ingestion or the native batch ingestion. So we chose Hadoop-based ingestion, and there were a few reasons for that. So the technical considerations was once maturity. When we started with Druid, and we, as you can mention, it was a few years ago. So the native batch ingestion didn't even exist yet. What was then the real-time ingestion wasn't mature enough. And either way, the documentation required you to use both batch and real-time ingestion if you needed to handle things like late arrival events, etc. So that was this solution was much more mature. Another thing was scalability. So we're launching on-demand Hadoop cluster on AWS, and we can scale them out or in as much as we want based on the data, or based on the volume of the data. So scalability was a major consideration for us. And finally, business requirements. So we're talking about advertising campaigns or trends. And in those use cases, what we usually care about is a day granularity or a one-day resolution. So ingesting data a few times a day or even once a day was enough for us. So we didn't need actual real-time ingestion. So if you are using the Hadoop-based ingestion, and we've seen in previous talks that some companies are using it, here are a few tips that can help you with that. So suppose you have multiple Hadoop clusters, or in like we do, we launched transient Hadoop clusters on the fly, and you want to ingest data from each one of them to separate data sources and do it in parallel. So what you can do is you can use affinity, which allows you to map between a middle manager and a specific data source. And in that way, you can connect a specific Hadoop cluster to a specific middle manager, hence ingesting data to a specific data source. The next thing is you need to understand that such Hadoop-based ingestion tasks actually run two MapReduce jobs by default. So the first one is called determined partitions, and it actually scans through all the data and understands or decides how many partitions or shards will need to be built based on the target rows per segment property. The second job is the one that actually, it's called index partitions, and is the one that actually builds those partitions based on the number of partitions that was decided in the first job. Now, if you want to speed up ingestion, you can actually set the num shards property in advance in your partition spec. And since you already set in advance the number of shards or partitions, it will actually skip the first MapReduce job and only do the second MapReduce job. Now, this is very useful in cases where you can, where you know in advance the volume of your data, and you can actually set the number of shards in advance. And lastly, with regards to ingestion, we have future plans to remove this kind of outdated Hadoop MapReduce dependency by either using the currently work in progress ingest data directly from Spark, or to use the native batch ingestion in a scalable way. And to summarize the ingestion section, we've seen there are multiple options to ingest data, and we explained why we chose the Hadoop-based ingestion, and also gave you tips on how to ingest data in parallel for multiple Hadoop clusters and how to speed up your Hadoop-based ingestion. So once we modeled and ingest our data, we need to carefully control the retention and deletion of the data. So in order to do that, you need to be familiar with three terms. Load routes, which are the part that determine which segments will be loaded into the cluster, either by an interval or by period, so say the last 30 days. And also, they decide how many replicas per segment will be loaded. The next thing you need to be familiar with are drop rules, which we are kind of the opposite. They decide when segments will be dropped from the cluster. However, segments that are dropped from the cluster are not yet deleted from deep storage. In order to permanently delete all information about the segment and remove it from deep storage, you need to periodically run kill tasks. Now, it's important to understand that segments have versions. Whenever you re-index data, a new version of that segment is being created. Those extra versions actually take up space in your deep storage. However, only the latest version of each segment is actually used, meaning it's marked with used equals 1 in the metadata store. Now, the other versions are not used anymore, but they are still take up storage. So what we advise you to do is to specify the interval of your kill task as wide as possible. This will only delete those segments that are marked as unused, meaning used equals 0. But it will not delete the versions that are still being used. So it will free up the unnecessary deep storage that those excessive versions are using. So let's take a concrete example. In one of our data sources, we had a 1-year retention period, and our deep storage is based, as I mentioned, on AWS S3. Now, for us, the kill task interval was whatever is older than 30 days, meaning delete all those unused versions that are older than 30 days. Still, we have the 1-year retention period, but only the versions that are outdated will be deleted after 30 days. This resulted in over 365 terabytes in our deep storage and in monthly cost of over $8,000. Now, the only thing we changed is the kill task interval, and we reduced it into 2 days, which means delete all the unused versions that are older than 2 days. So we significantly reduced our deep storage usage to 15 terabytes, and the monthly cost to $350 per month, which is over 95% improvement by just changing the kill task interval for a specific data source. Another cool thing we found out you can do is dimension-based TTL. So usually in databases, and Druid is no different. You'll delete and expunge data based on some kind of a timestamp column, right? So delete everything that's older than, say, 1 year. However, in some cases, you actually want to be picky, right? Cherry pick what you actually want to delete based on a value, delete and expunge based on the value of a specific dimension. So what you can do with Druid, and let's take this maybe not so classic GDBR use case, but still pretty much useful. Look at this example. You can see that we have data from the US and also from Sweden. So say US laws allow us to store data up to 90 days, but EU laws, in this case Sweden, only allows us to store up to 30 days of data. So we actually need to do some kind of TTL based on the value of this dimension. So the way to do it is actually to run an ingestion task that will add new data, as you can see in the bottom here, right? But it will also delete or actually retain only the data that we're allowed to still store. And you can see that only the US data that's older than 30 days is still here. So how do we actually do it? So we're running Hadoop-based ingestion with the multi-type input spec. That allows you to combine other input specs, so you can actually merge data from existing data from a Druid data source with new data from S3, for example. And in the type data source, you can actually filter or use a filter as part of your ingestion spec. And if you want to know more, check out this interesting blog post that my colleague and I wrote about generally retention deletion, and also specifically with regards to the dimension-based TTL. So that's to summarize the retention deletion part. And once we modeled the data, ingested it, and carefully retained or deleted it, we now need to query it, right? Because that's why we actually did all these things. So again, you probably know there are various methods to query Druid, either native queries, based on the JSON language or the Druid SQL. So maybe it's not a surprise that we use the native queries because, well, Druid SQL didn't even exist when we started with Druid. But the nice thing is that Druid SQL is expanding with each version, and now you can actually create Theta Sketch objects from Druid SQL starting from Druid version 0.14. With regards to query optimization, we chose to focus on two things here. So the first thing is you can tune your Theta Sketch size for performance. And Yakir mentioned that Theta Sketch is based on K and V, meaning you choose the size of K, or basically the size of the samples you take from your incoming data set. And the larger the size, or the larger the K sample that you take, the larger memory and footprint you'll have. So queries with size that's like we use 65,000 are heavy on resources, thus they will take more time. If you switch to size equals 4,000, this can significantly improve your speed, the speed of your queries. So this is very useful when there are no intersections. Again, as we talked about intersecting large sets and small sets and the problem with accuracy that can be there. But if you don't have any intersections, switching to size equals 4,000 can really help you. And it also have a relatively small effect on accuracy when there are no intersections. So the flip side of that is tuning Theta Sketch size for accuracy. So take a look at this Druid SQL query that we actually ran against one of our data sources. So there's an approximate count distinct theta function. You provide the Theta Sketch metric name and the data source, etc. And we ran it against a specific data source, and we got a result which is slightly under 29 million unique devices. However, when we added the size, meaning 65,000, as the second argument to this count distinct theta function, we got a much more accurate result, which is a little over 29 million. The reason is that this function has the size as an optional argument. And if you don't specify that, then the default is 16,000. And this is what happened in the first query. Now, once we actually provided this size and gave it size that's larger than 16,000, we got a much accurate result, a much more accurate result. But again, it might take more time because it needs more resources to compute those queries. So to summarize the query section, there are two ways to query data from Druid. We chose the native queries, and we showed you how you can tune Theta Sketch to balance between performance and accuracy. Two bonus slides here that I'll go over quickly to leave time for questions. So there are different considerations when you choose your hardware. For example, cost, performance, usage patterns. Here's an actual example for one of our production clusters. So we have a little under 10 data sources in that cluster. All are using Theta Sketch. The data set, the aggregated rolled up data size on that cluster is about 45 terabytes. So we chose to use 3 Broker nodes with 32 cores and 244 gigabytes RAM each. And for the historical nodes, we have very similar nodes. We have 20 nodes with similar spec. However, we chose to use very fast NVMe SSDs because that way Druid can pull the segment files very quickly from disk and load them into memory in order to serve queries. And actually, this is kind of similar to what ZeroTop folks have showed in the previous session. And another cool thing you can do in order to reduce costs and reduce operational overhead is to set up your dev cluster. So you usually need your production cluster, which is obvious, and you need your dev cluster to serve things like your the development environment for your developers or for internal holders to test alpha features, etc. Now, if you set up your dev cluster to use the same deep storage as your production cluster, and you create a read and write role for the production cluster, which will allow you to ingest new data from production, but you create a read-only role for the dev cluster, so that will prevent you from accidentally ingesting new data from the dev environment, and you periodically restore the metadata store from the production backup to the dev cluster, this will actually allow you to have kind of fully functioning dev cluster with all the data accessible as it is in production, of course, if your security allows that. And it reduces the cost significantly because you don't need to have the deep storage twice, and it reduces the operational overhead of ingesting data to the dev cluster. So we talked about how you can carefully model your data and roll it up using, for example, Theta Sketches. We showed you how we used Hadoop-based ingestion and how you can optimize that and do those things in order to ingest terabytes of data. We also showed you how you can use things like lookups and tune your Theta Sketches to balance between accuracy and performance in order to serve the most important thing for us and probably for many companies, which is customer-facing dashboards. And finally, we talked about how you can optimize things like your retention and deletion rules and carefully choose your hardware spec in order to do all that in a cost-efficient manner. So if you want to know more, we have a few things we care about. So Women in Big Data is a worldwide program that aims to inspire, connect, grow, and champion the success of women in the big data and analytics field. There are over 30 chapters and over 17,000 members worldwide, and everyone can join regardless of gender. So we really encourage you to find a chapter near you. If you are interested in how to do funnel analysis with Spark and Druid, check out this video recording from a meetup we had a few months ago. And finally, there's the Nielsen R&D Center tech blog, where there are very interesting posts about the things that we do at the Nielsen R&D Center, and the data retention and deletion post is one of them. So we thank you for participating, and now we'll be taking questions.
Fantastic. Thank you guys so much. There were so many good nuggets of information in that. Like, I was trying to keep notes of them all, and then I'm just like, I'm just going to have to go screenshot it later on. But definitely recommend those who didn't get to hear the entire presentation to go back, because you guys really threw down some awesome best practices. So appreciate it. If you have anybody in the audience, if you guys have any questions for Itai and Yakir, please send them through to the Q&A panel. It's way down at the bottom. We can't, if you raise your hand, I saw some people raise their hands. We can't unmute you, so please use the Q&A. So one of the first questions, which is an excellent question, and I think near and dear to the minds of lots of people who use Druid, doesn't Druid prefer to normalize data? So this is in response to your lookups in data modeling.
So I think that with regards to the example that we gave, it's probably better, and I think I explained why. It's probably better to do that lookups in order to have to change those values of those dimensions after fact, right? So if you use lookups, and again, lookups are kind of small, a very lightweight mapping between an ID and a value. So with regards to performance or things like denormalizing, I think it makes sense to use them in order to avoid problems like I mentioned with having to change the values later. Hope that answers the question.
Yeah, I think lookups are great when you have slowly changing dimensions and they're fairly small. But also Druid has recently introduced joins to some extent. So yes, in terms of the best performance and your best practices with Druid, denormalize is definitely the way to go. But that doesn't fit all use cases. So there's definitely some places where lookups and joins are appropriate. I actually have a question, because funnel analysis is, of course, near and dear to my heart, trying to understand just in general how people use the Druid website, for example. So what type of visualizations do you guys use for your funnel analysis? Druid in the back end, but how do you provide that data to your end customers?
Actually, so for funnel analysis, we have like a full-fledged product for that. We developed our own custom visualization for that. But the way that it works, like we are actually created a funnel visualization, and we show the number at each stage. So we let the customer define what are the different stages, and then you can see what are the stages, and you can also see the number of unique persons at every stage on a daily basis. It's getting updated from Druid, of course. So we have our own solution for that.
So you're saying that I'm going to have to go find a crack UI developer?
Not really, because I think that, and mainly in recent versions of Superset, the funnel chart is really great. So you can use the Superset for that, or I don't know if Imply is something similar or not.
Awesome. All right, so I'll get back to the other questions here. So do you use tiered storage, hot versus cold, and things to keep in mind during querying? That's the question. So I guess the question, do you guys use tiered storage?
So the answer is no. And I think it's, it's one of the things that we started looking into. But we haven't leveraged tiered storage, to be honest.
Okay, so what will the performance difference between aggregating from a flattened out data source versus counting and aggregating from a query using joins on lookups? Which scenario will cost more on infrastructure wise? So I guess they're asking what's the cost both in performance and both in infrastructure for completely flattening out your data source versus using lookups or joins?
So we haven't tested joins. I know it's an option to do with lookup, as I mentioned, but we use the let's call it the native way to do lookups, or the old way to do lookups. So I don't think we've noticed very significant performance effect when using those lookups. Again, in our use case, those lookups are relatively small, maybe a couple of I don't know, tens of thousands of entries. So it doesn't do much with regards to performance, and it still has the benefit of handling SCD and stuff like that.
Awesome. And what language are you used to implement this pipeline? Python, Node, Java, something else?
It's mainly the big data pieces, like data preparation and everything. It's Scala and Spark, and for some of the glue between the components, we are using for writing our pipelines. We are mainly using Python and Elf.
Fantastic. Well, thank you both, and thank you all out there for your questions. Links to the slides and the recording will follow, I promise. So, if you want to be like Yakir and Itai, and you want to tell your story about Druid, but maybe you don't feel comfortable speaking in front of hundreds of people, or you are comfortable speaking in hundreds of people, we want both of your guys' stories. So we have everything as simple as adding your use case to the Power By page on the Apache site, or doing a 5-minute interview with me or somebody on the team, doing a blog post, or we can arrange for you to speak at another Druid Summit or through a meetup. We'd love to hear all of that. And we can offer fame and fortune and riches, or at least some pretty good swag if you share your story. So please email us at community@imply.io. And we'll be happy to give you the latest and greatest information on what's going on in the Apache Druid community near you. And also want to put a note out there, keep an eye on all the community places for announcements about our new discourse-powered Druid community forum. We're really excited. We've been working for months on this based on some feedback we had from you all in the surveys we've done over the last few years. So all that being said, our next speaker is at the top of the hour. That's in 16 minutes, according to my, 15 minutes, according to my MacBook. And our speaker is Himanshu Gupta, who's a principal software engineer at Splunk. He's going to talk about running Druid on Kubernetes with the Druid operator, and it's not to be missed. So you have, in my calculations, exactly enough time to grab a beverage. So we'll see you all there.
Thank you.
Thank you. Bye.